Hello everyone and welcome back to PostNetwork Academy, your trusted resource for mastering concepts in data science, artificial intelligence, machine learning and beyond. My name is Bindeshwar and today we are starting an exciting journey into one of the fundamental aspects of probability, the axiomatic approach. So if you are student or researcher in data science or artificial intelligence, this would be useful for you. And in this lecture, I will cover the core principles or axioms that define probability, how these axioms lead to critical results like complement rule and additivity, and how these principles apply to real world scenarios in data science and AI. So let's get started. So to define axiomatic approach to probability, let us be a sample space for a random experiment. And that we will use to define axiomatic approach. And let A be an event that is a subset of S. Then PA is called a probability function if it satisfies the following axioms. The first one, non-negativity. That means PA that is greater than or equal to 0 for all A is subset of S. Second one, normalization. That means PS is 1. Let us see third one, additivity. So if A1, A2 are mutually exclusive, remember that if they are mutually exclusive and disjoint events, then PA A1 union A2 union till AN that will equal to PA1, PA2 and so on. So these are axioms of probability and these are called axiomatic approach. If you collectively they are called axiomatic approach. Now the rules I have explained, some implications you can see that means some principles are derived from that rules. So the probability of an impossible event is 0. That means P phi is 0. So P phi is 0 and we will prove all the implications. A probability of A complement that is equal to 1 minus PA. Third one, if A is subset of B, then PA is less than or equal to PB. Let us see some set theoretic interpretation of events, and that will help to understand many concepts in probability theory. So see that here, if at least one of the events A or B occurs, so how will you write? You will write like A union B, at least one, either it is in A or it is in B. Let us see the second one. Both events A and B occur. So you will denote it by intersection. That means both events occur. So also you know that A intersection B means elements which are common in both A and B. Third one, neither A nor B. So complement of A and complement of B. Events A occurs and B does not occur. So A intersection B complement. Exactly one of the events A or B occurs means A intersection B complement or A complement intersection B, and we will take union of both. Not more than one of the events A or B occurs. So more than one of the events A or B. That means A complement intersection B complement. You will take union, and A intersection B complement or A complement intersection B. We will use this formula, these concepts for calculating probabilities, and we will also do some numerical so that you will understand. Some results using probability function. So probability of the impossible event is 0. Probability of the complementary event for any event A, that would be P A complement, that would be 1 minus PA. Addition rule for two events. So PA union B is equal to PA plus PB minus, we will subtract the common events in both sets. Conditional probability we will discuss later. PA given B is equal to PA intersection B upon PB if PB is greater than 0, because numerator cannot be 0. We will discuss later. So these are some results. Now, independence of events. Two events A and B are independent if PA intersection B is equal to PA into PB. We will also do some numericals, and many questions we will understand later. Now let us prove P phi is 0. So here I have written for by the additivity axiom P S union phi is equal to PS and P phi. So you can say that here PS we have already told that PS is equal to 1. PS is equal to 1. So in the left side 1 plus P phi. So this will imply the value of P phi as 0 here. Now let us see to prove PA complement is equal to 1 minus PA. So you can also see that means A union A complement is yes. You know that if any set, and if you use its you take union of the set, that will be the whole universal set. In our case universal set is the sample space, and A intersection complement of AC, that would be phi. These results are from set theory. So by additivity axiom PA union AC, that would be PA and PA complement, and because PA union AC, that would be PS, that 1. So we get 1 is equal to PA plus PAC, and that means PA complement would be equal to 1 minus PA. To prove PA union B is equal to PA plus PB minus PA intersection B, simply by the definition of union. This is from set theory. I explained in the last video. Using the additivity axiom, P A union B is equal to PA plus PB minus P intersection B. So hope you understood. For more resources and videos, you can visit website www.postnetwork.co. You can also visit YouTube channel for videos and playlist. You can also visit Facebook page for a post and videos. You can also connect to LinkedIn page of Post Network Academy. So hope you understood. Thanks for watching the video.